So the Maclaurin series is a Taylor series expansion about point A equals 0. We need to find the value for f of x at a equals 0. So in our case, f of x equals sine of x. Then f of a equals sine of a. Then since a is 0, f of 0 equals sine of 0, which equals 0. Well, now we'll consider the formula for the Taylor series, and we will find the value of the derivatives required to find the Taylor series. So f of x equals the sum from n equals 0 to infinity of f of nth order infinity of f of a over n factorial times x minus a to the power of n. So this, as the expansion of this looks like this. So it's f of a over 0 factorial times x minus a to the power of 0 plus f prime of a over 1 factorial times x minus a to the first power plus the second order derivative of a over 2 factorial times x minus a to the power of 2, and so on. This equals 0 plus f prime of a over 1 factorial times x minus a plus f, the second order derivative of f of a over 2 factorial times x minus a squared, and so on. Well, now we need to find the derivative. So f prime of x equals cosine of x. Then f prime of 0 equals 1. Then the second order derivative of f of x equals negative sine of x. Then the second order derivative of f of 0 equals 0. Then the third order derivative of f of x equals negative cosine of x. Then the third order derivative of f of 0 equals negative 1. Well, then we find the Taylor series centered at a equals 0. So we find our Maclaurin series at a equals 0, f of x equals 1 over 1 factorial times x plus 0 over 2 factorial times x squared plus negative 1 over 3 factorial times x cubed, and so on. So sine of x equals x minus 1 over 6 x cubed plus 1 over 100